All right, in this video, I'm going to explain all the answers to the 9.4 worksheets, all three of them, starting with the first one, of course. So this one was on simplifying rational expressions. So the first one was 16r squared over 18r squared. And the way we simplify is you kind of want to take out a GCF in the top and the bottom of the rational expression. So you ask yourself what goes into both 16 and 8. Well, the answer is 8, so I pulled an 8 out of the 16r squared. And what goes into both r squared and r squared? Well, the answer is r squared. So in the top here, if I take an 8r squared out of that, I'm left with just 2, because 8r squared times 2 is 16r squared. And in the denominator, if you take out an 8r squared from that, you're just left with 8r squared times 1. And then you can cancel those two things out. So you can sort of think about it like you're reducing the 16 over 8, because if we reduce 16 over 8, you get 2 over 1. And if you divide r squared by r squared, you're just left with 1. So that's why we end up with just 2. So for number 2, we need to factor the numerator. So this factoring here, we're going to do GCF. So 2, we can factor a 2 out of this because we have 2c minus 4. So if you factor a 2 out, you're left with 2 times c minus 2, because if we factor a 2 out of 2c, you're just left with c. If you factor a 2 out of the minus 4, you're left with minus 2. So we factored a 2 out, and we have 2 times c minus 2. So that's what we have in the numerator. In the denominator, we just have c minus 2. Now, I wrote this as 1 times c minus 2. You don't really have to do that, but I did that just so it was very clear what we're crossing out. So since we have a factor of c minus 2 in the numerator and the denominator, we can cancel it out like that. And we're just left with 2 over 1, which is 2. So number 3, we have x minus 4 in the numerator and 3x squared minus 12x in the denominator. So in the numerator, I can't do anything to that. It's just x minus 4. So again, if you like I did in number 2, you can write 1 times x minus 4 if you prefer that, if it keeps you more organized. In the denominator, we have 3x squared minus 12x. So I'm going to factor a GCF out of that. So if I factor a GCF, we have 3 and 12. So I'll factor out a coefficient of 3 because that goes into both 3 and 12. Then we have x squared and x. So since those both have x terms, I'll take the lower degree out, and that would be x to the first. So I factored out a 3x. And if we do that, we are left with x minus 4. Because if you factor a 3x out of 3x squared, you're just left with x. And if you factor a 3x out of 12x, you're just left with 4. So now we have a factor of x minus 4 in the top and the bottom, so we can cross them out. And we're just left with 1 over 3x. All right, for number 4, we have 2 trinomials here. So this one was a little weird because you ended up not being able to cross anything out, but that does happen sometimes. So the way we factor this, these are what we call, I usually just call them regular trinomials because you have a coefficient of 1 in the front. There's nothing in front of that, v squared. So you ask yourself what adds to negative 7 that multiplies to negative 30. And the answer to that is negative 10 and 3. It's negative 10 plus 3 is negative 7. Negative 10 times 3 is negative 30. And then in the denominator, you ask yourself the same thing. What adds to negative 5? That multiplies to negative 14. Answer is negative 7 and 2. Now, we have a v minus 10 in the top. We don't have that in the bottom. We have a v plus 3 in the top. We don't have that in the bottom. So there's nothing that we can cancel out here. So what that means is we have no common factors in the top and bottom, which tells us that it's already simplified. You can't get any more simplified than that. All right, so number 5, same kind of thing. We've got 2 trinomials here. So we factor the top. We ask ourselves what adds to negative 3 that multiplies to negative 40, and that'll be negative 8 and 5. So we have k minus 8, k plus 5. For the bottom, what adds to negative 11 that multiplies to 24? That's negative 8 and negative 3. So we have k minus 8 times k minus 3. So now that we've factored all that, we look at if we have any like factors in the top and bottom, and we do. We have a k minus 8 and a k minus 8. Since those are exactly the same, we can cross them out. And then we're just left with k plus 5 over k minus 3. And that's all you can do there. So for this one, a little different because we have a difference of two squares. You just have to remember how to factor that. So remember, this is a squared minus b squared. And then the way we factor it is a plus b, a minus b. So that's difference of two squares. So b is 9, so it's y plus 9, y minus 9. Then in the bottom, we ask ourselves, this is a trinomial again, so we ask ourselves what adds to 10 that multiplies to 9, and that would be 1 and 9. So we have y plus 9, y plus 1. Since we have y plus 9 in the top and the bottom, you can cancel it out, and you're left with y minus 9 over y plus 1. All right, for number 7, in the numerator we have 4x cubed, so I'm not going to talk about that yet until we get to the bottom. So in the bottom, we have 12x squared minus 16x. So I will take a GCF out of that because 4 goes into both 12 and 16. So I'll take a 4 out. And we have x squared and x in both terms, so we can take out x. And if you factor a 4x out of 12x squared, you are left with 3x. And if you factor a 4x out of 16x, you're left with just 4. So in the bottom, we have 4x times 3x minus 4. Now let's go back to the top. So we had 4x cubed. The reason I wrote it as 4x times x squared, that's definitely the same thing. 4x cubed is definitely the same as this because x times x squared is x cubed. The reason I wrote this is so that it's very clear that we have the same factor here, 4x and 4x. So you can cancel those out. And then you're just left with x squared over 3x minus 4. If you didn't do that step and you just had 4x cubed over 4x times 3x minus 4, that would be okay because you can still see that you can cancel out the 4. And then you have x cubed over x, which you know is x to the third minus x to the first, which is just x squared. So you'd end up with the same answer. I just wrote it like that so it was very clear what factor we were crossing out. For number 8, we have a trinomial on the top. So b squared plus 3b minus 28. You ask yourself what adds to 3 that multiplies to negative 28. Answer to that is positive 7 and negative 4. So we have b plus 7, b minus 4 in the numerator. And then in the denominator, this is a difference of two squares. So when we factor that, we get b plus 7 times b minus 7, because 7 is the square root of 49. And then since we have a b plus 7 in the top and the bottom, we can cross them out. And we're left with b minus 4 over b minus 7. So that was the first part. That was just simplifying. So then we move on to multiplication, which is actually really similar. There's just one step added in the beginning, or I guess maybe two, depending on the problem. So for number 1, we have 6n over 10n times 4n over 10n cubed. So first step is to multiply across the numerators. So we have 6n times 4n here, and then 10n times 10n cubed in the denominator. And then I just simplify that. So 6 times 4 is 24. N times n is n squared in the numerator. And then we have 10 times 10 is 100. And then n times n cubed is n to the 4th. So this all right here is just the multiplication. So after this point, we're going to simplify. So I ask myself what goes into both the numerator and the denominator that I can factor out. So if I'm looking at just the coefficients, we have 24 over 100. I can factor a 4 out of both of those. And then we have n squared and n to the fourth, and I can factor an n squared out of those. So I'm going to factor a 4n squared out of both the numerator and the denominator so that I can cancel them out. So in the numerator, if I factor out a 4n squared right here, I'm left with 6 in the numerator because 4n squared times 6 is 24n squared. In the denominator, if I factor out a 4n squared, I'm left with 25n squared because if you factor a 4 out of 100, left with 25. If you factor out the n squared from the n to the fourth, you're left with n squared. So then once we get to that point, that makes it really clear to see that we have 4n squared in the top and in the bottom as factors. So we can cross those out, and we're just left with 6 over 25n squared. Number 2 is very similar. We just have 2 variables instead of just one. So for this, I kind of already did the first step here. You just multiply the numerators, multiply the denominators. So we have 5x y cubed times 10x squared y over 2x times 5x cubed y squared. So then just simplifying the numerator, we have 5 times 10 equals 50. X times x squared equals x cubed. Y cubed times y equals y to the fourth. So that's just simplifying the numerator there. In the denominator, we have 2 times 5 equals 10. And then x times x cubed equals x to the fourth. And then we just have y squared. So this is just simplifying, just multiplying and then simplifying the numerator and denominator. Now we're going to cancel out factors if we can. So first we want to ask ourselves what goes into both the numerator and the denominator that we can factor out. So start with your coefficients. We have 50 in the top and 10 in the bottom. We can definitely factor a 10 out of both of those. Then we move on to the x's, so that's what we did here. Then we move on to the x's. We have x cubed and x to the fourth. So you always take your lower degree, so we can factor an x cubed out of both of those. And that's what we've got here, x cubed over x cubed. And then we have y to the fourth and y squared, so take the lower degree. You can factor out a y squared. So then we need to figure out what we're left over with once we do that. So if we factor out 10 from 50, left with a 5 here in parentheses. We factored out an x cubed, so no more x's in the numerator. Factored out a y squared here. So if we factor that out of this y fourth, we're left with y squared here. Then in the denominator, we factored out a 10. So in parentheses, we factored that out of 10, so we're just left with 1 for our coefficient. We factored an x cubed out of this x to the fourth, so that leaves us with 1x here in parentheses. And then we factored a y squared out of this y squared, so no more y's left in the denominator. So then we have our factors that we can cancel out, and we're left with 5y squared over x. All right, so number 3, we have 3x over x squared minus 4 times x plus 2 over 1. So first, multiply across the numerators. So we have 3x times x plus 2. And then multiply the denominators. X squared minus 4 times 1 is just x squared minus 4. Then we factor. So the numerator is already factored. We can't do anything with that. So we just leave it as 3x times x plus 2. The denominator, we can factor it as x squared minus 4. That's a difference of 2 squares. So square root of 4 is 2. So the way we factor that is x plus 2, x minus 2. And then we have a factor in parentheses of x plus 2 in the top and the bottom, so you can cancel those out. And you're just left with 3x over x minus 2. For number 4 here, we've got x squared minus 3x minus 4 over x squared minus 16 times x plus 4 over 2x. Kind of did 2 steps in one here, so I multiplied across the denominators and factored at the same time. So If we factor this trinomial, x squared minus 3x minus 4, you ask yourself what adds to negative 3 that multiplies to negative 4. The answer is x minus 4, x plus 1, because negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4, and then times this x plus 4. So this right here, this came from here, and then the x plus 4 just came from this right here. In the denominator, we have a difference of two squares again. So square root of 16 is 4. So we have x plus 4, x minus 4, and then the 2x just came from right there. Then we have to look at what we can cross out. So let's erase these. So we have an x minus 4 in the numerator here and in the denominator. So we can cross those out. X plus 1, I don't have that in the denominator, so I'll move on to the next one. We've got x plus 4 and x plus 4. And then what we're left with is x plus 1 over 2x. Number 5, we have x minus 3 over x squared plus 2x minus 15 times x squared over 4x squared. So step 1. Again, I kind of did two steps in one here. So I multiplied the numerators, x minus 3 times x squared right here. And then in the denominator, I factored this right here. So ask yourself what adds to 2 that multiplies to negative 15. And the answer to that is positive 5 and negative 3. So we have x minus 5 times x minus 3, and then times 4x squared. And then I canceled out the x minus 3 and the x minus 3. And then I canceled out this x squared and this x squared. But notice that I did not cancel out the 4. Because just keep in mind we have x squared over 4x squared, which is the same thing as 4 times x squared. So you can think of these, since this is multiplication, 4 times x squared, it's like they're different factors. So you can cancel out the x squareds because they're exactly the same. But the 4, you don't have a 4 in the top, so you can't cancel that out. So just be careful there. So we're left with 1 in the numerator. Remember that if you cancel out everything that's in the numerator or denominator, you're left with a 1, not a 0. So be careful with that. So we have 1 in the numerator. It has to stay as a fraction. So that might help you remember to keep the 1 there. So there's a 1 in the numerator. We have a 4 here, this 4 right here in the denominator, and then x plus 5. All right, and then for number 6, we have a 5x squared plus 10x over x squared plus 7x plus 10 over 2x plus 4. Now this was just a polynomial by itself, so you just have to remember that you put that over 1, and now you've got two fractions. So first type of factoring we did here, this guy right here, 5x squared plus 10x, you can factor a GCF out of that. So ask yourself what goes into both 5x squared and 10x, and the answer is 5x. So that's where this came from right here. So we have 5x, and if you factor a 5x out, if you take it out of 5x squared, you're just left with x here. If you take a 5x out of 10x, you're left with 2. So that's where this came from right here, this whole thing. This whole thing is the same as this. We just factored out a 5x. And then this second part right here, 2x plus 4, we can factor a GCF out of that as well. So 2x plus 4, we factored out a 2 from that because 2 and 4 are both even, which means you can take out a 2. And then once you do that, if you factor out a 2, you're left with x plus 2 in parentheses. And then in the denominator, we have x squared plus 7x plus 10. Ask yourself what adds to 7 that multiplies to 10, and that's going to be 5 and 2. So when you factor that, you have x plus 5 times x plus 2. And now we have to cancel everything. So I'm going to erase all these colors so it doesn't look as confusing. So we cancel our factors that we have in the top and the bottom. So first I'm looking at 5x. I don't have a 5x in the denominator, so I'll move on. Next, we have x plus 2. We do have that in the denominator. Now, notice we have 2 x plus 2's in the numerator and only 1 x plus 2 in the denominator. Since there's only 1 in the denominator, that means you only have 1 to cancel out. So we need to leave this other x plus 2 up here. So that's equal to, I skipped a step, so I'm going to write that step in here. So we're left with 5x times 2x plus 2 over x plus 5. And when we multiply the 5 and the 2, that's where this 10 comes from. So we have 10x times x plus 2 over x plus 5. That's what we're left with. So this last section, only 4 problems. This was on dividing rational expressions, and this is really similar to multiplying. There's just that one step in the beginning that's different where you have to do keep, change, flip. So number 1 was 4n over 5n squared divided by 2n over 4n cubed. So step 1 is keep, change, flip, or also known as multiplying by the reciprocal. So we have 4n over 5n squared times 4n cubed over 2n. Just flip that second fraction. Now that we've done that, this is just a multiplication problem, just like the last worksheet. So in the numerator, we have 4n times 4n cubed. Denominator, 5n times 2n. 4 times 4 is 16 in the numerator. N times n cubed is n to the 4th. Then in the denominator, 5 times 2 is 10. N squared times n is n cubed. And then we need to figure out what we can take out of both the numerator and denominator. So you look at your coefficients first. We have 16 and 10. The largest number we can factor out of both of those is 2. So that's where this 2 came from. And when you do that, in the numerator, we're left with 8 in parentheses, because 16 divided by 2 is 8. In the denominator, if you factor the 2 out, you're left with 5 for your coefficient. Now let's look at the n's. So we have n to the 4th and n cubed. You always take out the lower degree. So we factored out an n cubed. And in the numerator, that leaves us with 1n, n to the 1st. And in the denominator, we don't have any n's left. So now that we factored 2n cubed out of both the top and bottom, we can cancel them out. And you're just left with 8n over 5. So number 2, we've got x squared minus 25 over x squared plus 10x plus 25 divided by x plus 2. So again, we want this as a fraction. So just like with whole numbers, you put it over 1. And now we can do our keep, change, flip. So keep the first fraction the same, change to multiplication, flip the second fraction. And then we multiply across the numerator. X squared minus 25 times 1 is just x squared minus 20. All right, so x squared minus 25 in the numerator. Then in the denominator, we have this trinomial, x squared plus 10x plus 25 times x plus 2. And then it's time to factor. So x squared minus 25 is a difference of 2 squares. Square root of 25 is 5. So we have x plus 5 times x minus 5 in the numerator. And then in the denominator, this is a trinomial. So you ask yourself, what adds to 10 that multiplies to 25? That would be 5 and 5. So in the denominator, we have x plus 5, x plus 5. Then it looks like I made a little mistake here. There should be x plus 2 and I wrote minus. So if we just change this to a plus here, to a plus here, we'll be fine. All right, so we have x plus 5 in the numerator, and we have an x plus 5 in the denominator. Now we have 2 x plus 5s in the denominator, but we only have 1 in the numerator, so you can only cancel out 1. Then we've got an x minus 5, and we don't have that down here, so you leave that. And that's it. So we're left with x minus 5 in the numerator, then x plus 5 times x plus 2 in the denominator. For number 3, same process at the beginning. we've got division, so we change it to multiplication and take the reciprocal of the second fraction, so just keep, change, flip, and then multiply the numerators, so 2x squared minus 4x times 4x, and then in the denominator 2x cubed times x minus 2, so that's just the keep, change, flip step, and then multiply the numerators, multiply the denominators. Now we factor and simplify. So first, this 2x squared minus 4x, we're going to do a GCF with that because 2 and 4, you can pull a 2 out of that. Then we have x squared and x. You can pull an x out of that. So that's what we'll do. So if we pull out a 2x from both of these right here, what we're left with is x minus 2. So if you pull a 2x out of 2x squared, you're left with x. If you pull a 2x out of 4x, you're left with 2. And then this 4x just stays the same right here. And then in the denominator, not much factoring we can do there. It's already factored, so we're ready to cancel stuff out. So we have 2x times x minus 2, and we'll cancel out the x minus 2 right away because that's very obvious to me that that can go away. Then once we do that, we're left with 2x times 4x up here, and then 2x cubed. 2 times 4 is 8. X times x is x squared. So now that I have it right here, I can see that I can actually cancel more out because 8 and 2 are both even, which means I can factor a 2 out. We have an x squared and an x cubed, which means I can factor out the lower degree, which is x squared. So if I factor a 2x squared out of 8x squared right here, I'm left with just 4. And if I factor a 2x squared out of 2x cubed, I'm just left with x to the first, 1x to the first. So then these guys cancel, and we're left with 4 over x. Last one, we have 3x plus 9 over 2x divided by x squared minus 3x minus 18 over x squared. Step 1 is keep, change, flip, so keep this the same, change this to multiplication, flip the second fraction. Then we multiply the numerators here, so 3x plus 9 times x squared. Multiply the denominators here, 2x times x squared minus 3x minus 18, being careful to leave polynomials in parentheses. Then we factor. So in the numerator, the only thing I want to do is factor a 3 out of this set of parentheses, because 3 goes into both 3 and 9. So when we do that, if we factor a 3 out of that, we're left with 3 times x plus 3. Then this x squared just stays the same. Can't do anything with that yet. And then in the denominator, this 2x right here stays where it is. Can't do anything yet. Then I'm going to factor this trinomial by asking myself what adds to negative 3 that multiplies to negative 18. The answer to that is 3 and negative 6. So when we factor this trinomial, we have x plus 3, x minus 6. And then once I have it all written out like this, I'm going to factor out or cancel out the most obvious factors. So first, we've got x plus 3 and x plus 3. So let's just get rid of those right away. And then I'll simplify a little more, see if there's anything else I can do. So in the numerator, what we're left with is 3 times x squared right here. In the denominator, we're left with 2x times x minus 6. So we've got a 3 and a 2 for our coefficients. Can't do anything with that. We have x squared and x as another factor, so I can cancel 1x out of each of those. So that's what I did here. So I took 1x, or x to the first, out of this x squared right here, leaves us with x. And I took this x right out, and that just leaves us with 2 times x minus 6. Cancel those guys out, and we're left with 3x over 2x minus 6. And that is it.